All right, welcome to the first recitation session of our mentorship program in calculus. Earlier this week, I have sent a couple of questions for you to solve as a revision of what we have studied in the first chapter of calculus, right? So here I'm going to solve the same questions, and then you can use it to correct yourself and see where you make a mistake if there is any. All right, so the first thing we discussed last week was a function, right? So if you remember, we defined a function. We said that a function is a mathematical model that relates input. Okay, so input, this is the independent variable. We can call it the independent to an output, which output in this case is your dependent variable. So basically what you are asked to do here is try to find a function that relates, for example, in this first question, express the area of the perimeter area and the perimeter of an equilateral triangle as a function of the triangle's side length. Okay, so what we have here, let's start by sketching our reference triangle. So we have an equilateral triangle, which we can draw something like this. Okay, so we assume that this is equilateral. So this, and this is equal. Okay, so now let's assume these sides, which are equal, are represented by x. Okay, so this will be x, this will be x, and this will be x. Okay, so let's start with the easiest one, perimeter. Okay, the perimeter P of x, okay, is just the summation of the length of the sides of a triangle. Okay, so here we have three sides, both are x, so the perimeter is going to be x plus x plus x. So this is 3x. Okay, now for the area, we know that the area as a function of x also, so a of x, this is going to be, we know the formula to calculate the area of a triangle is 1/2 base times height. Okay, now if we look at this, our reference triangle, we can assume this to be our base of the triangle from here to here. So this whole length x is our base. Okay, for the height, we can assume, or not assumption, we can see that from here to here, this is the height of this triangle. Okay, and this height will divide this triangle at exactly half of the triangle. Okay, so this is going to be like x/2, and let's call this h. Okay, so if we consider the left-hand side of the triangle, we have something like this now. So we have a base here. Let's draw the height in red. We have a height. Okay, and we have a hypotenuse for the triangle. So we know that this side is x/2. This is the hypotenuse is x, and this is h. So we need to find what is h. Okay, so by Pythagoras theorem, we know that x squared is equals to h squared plus x/2 all squared. Now this is going to be x squared is equals to h squared plus x squared over 4. Now we are trying to solve for h, right? So if we take x squared over 4 to the other side, so we have h squared is equals to x squared minus x squared over 4. Okay, so this is like over 1. If we take the LCM of this, so we have 4 here, so 1 into 4 is 4. 4 times x squared, so we have 4x squared, then minus x squared. Okay, and this is equals to h squared, and this can also be written as 3x squared, because 4x squared minus x squared is 3x squared, so we have over 4, right? So if we take the square root, in order to get h, we need to take the square root of both sides. So h is going to be the square root of 3x squared over 4. And this is the same thing as taking the square root of 3x squared divided by the square root of 4. And now this is equals to, so because x is squared, we can factorize it outside the square, and the square will cancel the square root. So we have something like x square root of 3 over 4. Now this is h, right? So this is what we are looking for. This is the height of this triangle. Okay, so this is h. Now, if we go back to what we have above here, we said that the area, okay, let's write it here, a of x is equals to 1 over 2, the base times the height. Now we know the base is x, and we now have the expression for the height of this triangle. So this is going to be 1 over 2 x times x square root of 3 over 4. Okay. Okay. So I think everything is correct, right? Okay. Sorry. I believe I have a mistake here. Okay. So here, because we need to take a square root of 4 also, so this should be square root of 4 is 2. Okay. Sorry, my mistake. So here we should have a 2 here, right? So we have taken the square root of both the numerator and denominator. So if we change here, so this is not 4, this is 2. Okay, and if we multiply this expression here, so a of x is going to be 1 over 2 times 2, so this is going to be 4. So we have x squared square root of 3, 2 times 2 is 4, divided by 4. Okay, and now this is our expression for the area, and if we write the perimeter as above, just taking it from above, p of x is equals to 3x. Now this is our final solution here. Okay, now moving into the next question in this session. Okay, so we have this. A point P in the first quadrant lies on the graph of a function f of x equals to square root of x. Now express the coordinate of P as a function of a slope of the line joining P to the origin. Okay, so the best way to approach this is to start by sketching. Okay, so let's try to sketch this function in a simple xy coordinate system. Okay, so this is our x, This is our y. Okay, so the function f of x equals to square root of x is something like this. Okay, so we can represent this as y equals to f of x. Okay, if we take any arbitrary point on this line, okay, like here, let's call this p. Okay, and the coordinate of p here is going to be x comma y. Okay, so because this place is our arbitrary x and this is our arbitrary y. Okay, so we have taken a point p which is in the first quadrant, so because we are using the first quadrant here. Okay, so p has a coordinate of x comma y. Okay, but we know that y is equals to f of x, which is equals to square root of x, right? We have it here, y equals to f of x, which is equals to square root of x. So this is equivalent to p of x comma square root of x, right? Because we know that y is equals to square root of x. Now this is done. The next thing is we need to express this coordinate p, the coordinate of the point p, as a function of the slope of a line joining p to the origin. Now, if we take any line, okay, let's draw a line, any line that coordinates this point p to the origin. For example, this line. Okay, this green line connects the point P we have on the graph to the origin. And if you recall, the equation of a line, any linear line, the equation is y equals to mx plus c. Okay, m here is your slope and c is the intercept on the y-axis. So since this slope is passing through the origin, okay, so we have, okay, since it passes the origin, then we have c is equals to 0. Okay, perfect. Then what do we do from here? So we know that c is 0 now. Then we can write the equation of this line as y is equals to m times x. Okay, but now we also know that y is equals to square root of x, because if you look here, let's take a pointer. Okay, at this point of intersection, the line and the graph of the function, they meet at this point of intersection, and we know that at that point y is equals to square root of x. Okay, so what we can do is, instead of writing y, we can say that the square root of x is equals to m over x. Okay, if we divide through by x, this x cancel x, we have expression now as m is equals to square root of x over x. Okay, if you remember from your indices, this can be written as x to the power of 1 over 2 divided by x. Okay, so by indices, when you have a division, you can subtract the power, right? So we have m is equals to x to the power of 1 over 2 minus 1, which is x to the power of minus 1 over 2. X to the power of minus 1 over 2 is the same thing as the square root of x. So now we have an expression for m. We know that m is equals to 1 over the square root of x. Sorry, 1 over the square root of x. Okay, now let's just highlight this and keep it there. Okay. Okay, if we make x the subject of the formula here, so first by taking the reciprocal of this, okay, so we can have that root x, why do I keep writing 3? Root x is equals to 1 over m. Okay, And now if we square both sides, then we have x is equals to what? 1 over m squared. Okay, so highlight this and reserve it. Okay, so we have expression for x and for y. Now, if we go back to the question here, so we are trying to express this term here, okay, p of x comma y, which is equals to p of x comma root x. Okay, but we are not looking to use x because the question says express this as a function of the slope of the line joining p. So we need to express this as a function of m. Okay, so the point p x comma root x is equals to, okay, so p of, now instead of x, we can see that x is 1 over m squared. So we can write it as 1 over m squared, comma, okay, and we have it above there, okay, just here, that root x is 1 over m. So we can have it as comma 1 over m. Okay, and this is our final answer. Okay, now we have expressed the point P in terms of the slope of the line joining P and the origin. All right. Now let's go to, okay. So I'm going to stop here, and then in the next video, I will solve the remaining question because they are not related. We have domain and range. Okay, see you in the next video.